Hi students, today structure of atom, already we did one video, and we are continuing the same chapter. So already I explained the how the structure of atom will be in protons, electrons, and the J.J. Thomson's model of an atom, Rutherford model, what are its drawbacks, and we also discussed Bohr's model, and we also discussed what are neutrons. Then we continue how are electrons distributed in different orbitals. According to Bohr's model, there are many energy levels like shells are present. So the electrons are distributed in these shells, he told. So how the distribution takes place? So the distribution of electrons into different orbits of an atom are suggested by Bohr and Bury. So we have to follow some rules for writing the number of electrons in different energy levels or shells. Let's see. The maximum number of electrons present in a shell is given by a formula. So what is that formula? 2n square. So where n is the number of the shell. So it is the n is the orbital number or energy level. So first shell, when it is a first shell, n is equal to 1. So first shell, K shell, n is equal to 1. So we can write how many electrons can be accommodated in a K shell. So K is shell is first shell, n is equal to 1. So 2n square. So we can write 2 into n is 1 because first shell into square, that is equal to 2. So in the first shell, 2 electrons can be accommodated. So like this, here it is given. So first orbit or K shell will be 2 into 1 square, so 2. In the second shell or L shell, so here n is equal to, L shell is n is equal to 2. So 2 into 2 square because 2n square. So a maximum how many electrons it can be accommodated? 8. And the third orbit or M shell, 3. Third shell M shell, so 2 into 3 square, 18. And the fourth orbit or N shell, fourth orbit, so 2 into 4 square, 32. So like this we can calculate the number of electrons present in a shell. So the maximum number of electrons that can be accommodated in the outermost orbit is 8 because 8 is the stable electronic configuration. So the maximum number of electrons that an atom can accommodate in the outermost orbit is 8. Electrons are not accommodated in a given shell unless the inner shells are filled. First the inner shell will be filled, means first the K shell will be filled, afterwards only it will L shell will be filled, afterwards only M shell will be filled. So the electrons will not be filled outer shells unless the inner shells are first accommodated. So in a stepwise manner, first K shell will be filled, maximum 2 electrons can fill. After that it will go into the L shell. When it is completely filled, then it is going to the M shell, afterward N shell, like this. So the electrons filling process will be continuing. So atomic structure of the first 18 elements are given here. See, first hydrogen is the first element, only 1 electron because atomic number 1, so it is present in the K shell. Then helium they gave, so atomic number 2, so 2 electrons are there in the K shell. So as K shell has the maximum capacity of only 2, so next is lithium. It have 3, so 2 are accommodated in the K shell and the remaining 1, so 1, 2, 3 because atomic number 3. So in the L shell 1 electron. Beryllium 4, atomic number 4, so 4 electrons, 2 electrons in the K shell and L shell 2 electrons. And boron 5, so continuation of this, 2 electrons in the K shell and 3 electrons in the L shell. So 2 electrons in the K shell, 4 electrons in the L shell carbon. Like this they continued. When full 8 electrons are filled, like in neon, 2 electrons in the K shell, L electrons in the L shell. So fully filled, it will go into the next shell, M shell, with 1 electron outside. Like this it will be filled. So 18 elements are given with their shells completely filled like this. Next, so make a static atomic model displaying electronic configuration of the first 18 elements. We can do this very easy. So the atomic model showing the electronic configuration of these elements having the electrons distributed in the shells. So next, See, write the distribution of electrons in carbon and sodium atoms, they told. So what is the carbon atom? Atomic number, carbon atom is 6. So 6 electrons should be there. So first shell K, second shell L. So first we will write K shell maximum is 2 and L shell is 4 because 2 plus 4 6. So we can write K shell, it's a nucleus, and 2 electrons in the K shell and remaining 4 electrons in the L shell. Like this we can write. Next is sodium atom. So sodium, its atomic number is 11. So how it is distributed? 2, 8, maximum is 8 for L. So next remaining is 1. So 2 plus 8, 10 plus 1, 11. Correct it is. So we will write nucleus. K shell, 3 shells are there. So we draw 3 shells. K, L, M. So 2 electrons in the K shell, 8 electrons in the L shell. 1, 2, 3, 4, 5, 6, 7, 8. And the M shell, 1 electron. Like this we can draw. We can just check in here also. So carbon and sodium. So next, if K and L shells of an atom are full, then what would be the total number of electrons in the atom? If K and L shells are full, so this is K and L shells are full. What is the number of electrons in the atom? 2 plus 8, 10. So the number of electrons will be 10. So and that is nothing but neon. Then we will see what is valency, the important concept. So we also learned that how electrons in an atom are arranged in different shells and orbits. So according to the Niels Bohr model of an atom. So we also learned now what are the rules to fill the electrons and how the electrons are filled in the outermost shells of an atom. And the electrons which are present in the outermost shell, so which are present in the outermost shell are known as valency electrons. The electrons which are present in the outermost shell, not inner shells, we don't consider inner shells, outermost shell are known as valency electrons. From Bohr-Bury scheme, we also know that the outermost shell of an atom can accommodate a maximum of 8 electrons. So it was observed that the atoms of elements completely filled 8 electrons in the outermost show little chemical activity. If the electrons are fully filled, so it is fully filled with 8 electrons, then they will not show chemical activity or little chemical activity. In other words, we can say their combining capacity or valency is nothing. It is 0. So of these inert elements, here we can see, for example, helium, only one shell is there, it is completely filled because K shell's capacity is 2, it is completely filled. And in neon, so outermost shell 8 electrons, it is completely filled. And in argon, here also outermost shell with 8 electrons, it is completely filled. So there is no free valency electrons. There are no free electrons to form a bond with other atoms. So no chemical activity is seen in these elements. So they are called inert gases, inert elements. Inert means it cannot mingle with other or make chemical activity with the other elements like helium, neon, argon, like this. So of these inert elements, the helium has 2 electrons in its outermost shell. As already told, helium has 2 electrons in its outermost shell, and all other elements have atoms with 8 electrons in their outermost shell. So the combining capacity of an atom of element is their tendency to react and form molecules with atoms of same or different elements was thus explained as an attempt to attain a fully filled outermost shell. So what is valency? So it is the capacity, combining capacity of an element so that it will react with other atoms to form molecules so that they will attain the fully filled outermost shell. So an outermost shell should have 8 electrons, which was said to possess an octet. So it should have 8 electrons in the outside to form a stable structure. So if it is less than 8 electrons, then it will react with other atoms or elements to form molecules. So atoms would thus react to achieve an octet in the outermost shell. How it is achieving an octet in the outermost shell? It is by sharing. How it will share? By gaining or losing the electrons, or the number of electrons gained or lost or shared so as to make the octet of electrons in the outermost shell gives us directly the combining capacity of the element. So that is valency discussed in the previous chapter. We know what is valency. It is a combining capacity of an element. The free electrons will combine to form the octet structure by combining with other elements. For example, here hydrogen, lithium, sodium contain one electron each in the outermost shell. If we see the hydrogen, it has only one. Lithium have one, and sodium we can see one. So these are first group elements because they have one electron in the outermost shell. So as they have only one electron in their outermost shell, they have valency 1. So it can share that one electron, it can lose that one electron. So therefore each one of them can lose one electron, so that they have valency of 1. Then what is the valency of magnesium, aluminum? It is 2 or 3 respectively, because magnesium has 2 electrons in its outermost shell, aluminum has 3 electrons in its outermost shell, and if the number of electrons in the outermost shell of an atom is close to its full capacity, then the valency is determined in different way. For example, fluorine atom has 7 electrons in the outermost shell and its valency could be 7, but it is easier for the fluorine to gain 1 electron instead of losing 7 electrons. So how? I will make one video how to calculate the valency of electrons. So you can check that video next after this. So hence its valency is determining by subtracting 7 electrons from the octet, and thus gives a valency of 1 for fluorine. So valency can be calculated in similar manner for oxygen also. So therefore an atom of each element has a definite combining capacity. So every atom will have some combining capacity. And it is called its valency. So valency of first 18 elements are given in this table. Let's see. So valency of hydrogen 1. So helium 0. Lithium 1. Beryllium 2. Boron 3. Carbon 4. So like this the valencies of first 18 elements are given. So we will discuss this in the next video. So how to calculate the valency then. So here one question is there. We will answer this for your better understanding. How will you find the valency of chlorine, sulfur and magnesium? So let's find the valency of chlorine, sulfur and magnesium. So first one is chlorine. Chlorine atomic number is 17. Right. Then we will write its electronic configuration or how the electrons are distributed. So first K shell 2. L shell 8 and 2 plus 8 10, so we need 7. So in the M shell KLM, M shell 7. So I will just draw it also so that it will become easy for you, for your understanding. So 3 shells are there, so I drawn 3 structures. This is nucleus. So 2 electrons in the K shell, 8 electrons, 3 4 5 6 7 8. And in the chlorine 1 2 3 4 5 6 7. So we take valency means only outermost shell electrons. It is 7. So is it easy to remove 7 or to just add 1 to make it octet? Because outermost shell should become 8, should have 8 electrons to become a stable structure. So removing 7 electrons is difficult. It consumes so much of energy than adding 1 electron. So its valency is 1. Let's see here. So chlorine, its valency is 1. Then one more they asked. Which one? Sulfur. Let's write sulfur. So sulfur, its electron, so its atomic number is 16. So I will write 286. So I am not drawing this because 6 is the, I think you already understood. So 6 is the outermost electron. So it has 6 electrons in the outermost shell. Removing 6 is easy, or adding just 2 electrons to make it 8 is easy. We know that adding 2 electrons is very easy. So its valency is 2. Then one more they gave, magnesium. So what is its atomic number? Just see the table. So it is 12. So we write this also, 282. So in the outermost orbital 2 are there. So its valency is 2 only. So removing 2 electrons is easy than adding 6 electrons to this. So 2 is its valency. So that is the answer. Next, what is atomic number and mass number? So we know that protons are present in the nucleus. We already discussed the protons, positively charged particles, are present in an atom. It is the number of protons of an atom which determines its atomic number. So atomic number means nothing but number of how many protons are there, and it is denoted by Z. So all atoms have same atomic, all atoms of an element have same atomic number Z. In fact, elements are defined by the number of protons they possess. For example, we are telling here atomic number SNO 1, 2, 3, and it will be definite. So how we got this atomic number? By means of number of protons. So for example, hydrogen, first atomic number 1 we told, because in hydrogen atom only one proton is present. Similarly, carbon we say Z is equal to 6. It means the number of protons is 6. Like that we calculate the atomic number and represent it by Z. Then next is what is mass number. So we studied the properties of subatomic particles. We can conclude that the mass of an atom is practically because of, not because of electrons, because they are very light, because of protons and neutrons present in the nucleus. So mass we can calculate by so protons and neutrons present in the nucleus. So mass of a carbon is 12 mu because it has 6 protons and 6 neutrons. So we can easily say mass number is nothing but proton number plus neutron number. That is nothing but 6 mu plus 6 mu, 6 protons plus 6 neutrons, that is equal to 12 mu. Similarly, mass of aluminium is 27. That means 13 protons and 14 neutrons are present here, and it is represented by A. So mass number is nothing but total number of protons and neutrons. So we can represent an element like this. If we say, for example, symbol of an element X, then mass number is A, is represented up by A, and atomic number down Z. So let's represent it for carbon. Let's see, carbon. So A is mass number 12 they gave, right, like this, and atomic number is 6. Like this we can represent. For example, they gave nitrogen, so 14, 7, 9, N. Then next is, see, if the number of electrons in an atom is 8 and the number of protons is also 8, what is the atomic number? We already know. So what is the atomic number? Number of protons. So 8 only. What is the charge of the on the atom? So positive charge. No. Then what is with the help of table 4.1, find out the mass number of oxygen and sulfur atom. So oxygen and sulfur they told with the help of table. Oxygen, so number of protons are 8 and the number of neutrons are 8. So mass number is 8 plus 8, 16. And they told for sulfur also. Sulfur, so number of protons is 16, number of neutrons is 16. So 16 plus 16, 32. So like this we can easily find out. Next one is isotopes. So in nature, a number of atoms of some elements have been identified which have same atomic number but they have different mass numbers. For example, in hydrogen atom if we take, there are 3 atomic species like this. They are like protium, deuterium and tritium. They have same atomic number 1. So we can see here down. Yes, no? And mass number is differing. So, so other examples also we can say, like for carbon also, carbon 12 and carbon 14, and for chlorine also 35 chlorine, 37 chlorine. So on the basis of these examples we can say that atoms of same element having same atomic number but have different mass numbers. So therefore they are called isotopes. We gave the examples of hydrogen, chlorine, carbon, etc. Then many elements. So many elements consist of a mixture of isotopes also. Each isotope of an element is a pure substance. So we can see many elements consist so many isotopes and each isotope is a pure substance. So the chemical properties of these isotopes are similar. but their appearance will be different. Their physical properties will be different. So for example, if it's take chlorine, it occurs in two isotopic forms, like with mass 35 and 37. So it is in the ratio 3:1. So then we'll get doubt which mass we should take. So we can take the average of the mass of both the chlorine atoms. For example, they told in 3:1 ratio. That is why 35 is in, so if we take 3:1 ratio of 35 mu and 37 mu. So 35 into 3/4. So and 37 into 1/4. So like this we can conclude. So in the fraction we can take into 100. So we will get like this. So we will get average of both 35.5 mu. So the mass of an atom of any natural atom is taken as average mass of all the naturally occurring isotopes. If an element has no isotope, then the same mass we can easily taken. So this does not mean that any one atom of chlorine has fractional mass. We are calculating the average mass we got in decimal points. That means it don't have fractional mass, because for our convenience we are taking it as an average mass. Then so that is about isotopes, and we'll see applications. So these isotopes have so many applications. They have special properties used in various fields. Like an isotope of uranium is used as fuel in nuclear reactors. Isotope of cobalt is used in cancer, treatment of cancer, and iodine is used in treatment of goiter. So next, last topic of this lesson, isobars. So what do you mean by isobars? So for example, we took two elements, calcium atomic number 20 and argon atomic number 18. So the number of protons in these atoms is different, but the mass number of both the elements is 40. Though the protons is different, means atomic number different, but their mass number is same, reverse of isotope. So the total number of nucleons is same in the atoms of this pair of elements. These are called isobars. Thank you.